The NanoFlowSizer is a particle sizing instrument developed by in-process LSP and based on spatially resolved dynamic light scattering, or in short, SR-DLS. This technique is an advanced form of dynamic light scattering and allows for improved capabilities, such as particle size measurements at high turbidities and of flowing suspensions. But how does it work? DLS measurements use light to illuminate a suspension, where particles are continuously moving due to Brownian motion. It is this fundamental motion of suspended particles that is exploited to extract particle size information. As particles diffuse through the light beam, they scatter light back to a detector, where constructive and destructive interference happens. The relative positions of particles change in time, and this results in a fluctuating change in intensity at the detector in time. These fluctuations are analyzed with autocorrelation functions, which show how quickly the signal changes over time. Such autocorrelation functions are then fitted to obtain the diffusion constants of the particles in suspension, and the hydrodynamic radius of particles is calculated. The NanoFlowSizer is based on DLS, but has a special hardware configuration which allows for spatially resolved DLS. How is it different from standard DLS, and what advantages does it have? Using the principles of optical coherence tomography, we can determine the optical path length of light, indicating how far the light has traveled. This capability enables us to resolve the scattering volume at different depths within the sample. For each sample depth, scattered light intensity fluctuations can be measured, and a correlation function, and as a result, the particle size distribution can be calculated. The ability to resolve the scattered signal in depth allows the simultaneous acquisition and averaging of around 1,000 measurements, which results in very short measurement times of a few seconds. These capabilities also allow for SR-DLS measurements in conditions typically challenging for standard DLS, such as high turbidity samples. The main limitation of standard DLS for analyzing high turbidity samples is that the technique requires single scattering events for reliable measurements. But for concentrated suspensions, multiple scattering will become dominant after a certain depth. For the NanoFlowSizer, the signal will be analyzed at every depth, and the point from which multiple scattering happens will be determined. This unique feature of SR-DLS allows appropriate automatic data treatment by discarding signal from depths in which multiple scattering dominates, resulting in accurate particle size measurements at a very broad range of turbidities. The NanoFlowSizer is a process analytical technology tool and can be used to monitor particle sizes directly in flowing suspensions. Inside tubing, a flow profile is formed, and particles at different depths flow at different velocities, with particles near the walls flowing slower than the particles deep in tubing. This means that the apparent particle size would be incorrectly shifted at every depth. In contrast, the NanoFlowSizer can measure particle velocity at every depth, and therefore the flow profile can be characterized. This enables correction of flow-induced effects, resulting in accurate particle size measurements. These capabilities make the NanoFlowSizer, based on spatially resolved dynamic light scattering, the only instrument capable of measuring particle size in both static and flowing suspensions, directly at their native turbidity levels. That means you can trust every measurement, even in the most complex and demanding conditions. The NanoFlowSizer is a modular system that can be integrated inline and online in a process, or used as an at-line and offline tool. Furthermore, the unique geometry of the NanoFlowSizer allows measurements not only in vials and pipes, but also in flasks, syringes, and most transparent closed containers. From early process development to GMP manufacturing, the NanoFlowSizer has a place in every process. Want to discover the NanoFlowSizer? Visit our website or contact us today.